Hi, today we are looking at 4.5, day 2. So we are going to continue working with our solving rational equations. The difference with today is the previous section we looked at ones where you had just single fraction equals single fraction or a single term, and we could use cross multiplying to solve. Today we're going to look at ones where this cross multiplying won't work, and we're going to look at how we can solve it using the least common denominator, that least common multiple instead. It's going to be kind of a similar process we did when we were solving complex fractions when we were using that second method for those. But it says basically when a rational equation is not expressed as a proportion, meaning fraction equals fraction, you can solve it by multiplying each side of the equation by the least common denominator of all of your rational expressions. So the other way you could technically do this, which I'm not going to show, is you could technically add the fractions together on the one side and then it would be a proportion, so you could do your cross multiplying. So you could basically combine all of these and make it so you could use cross multiplying on all of them. That does not always work out super nice though with your equations, and depending on what's in your denominator, it might kind of turn into a bit of a mess. So what, again, I'm going to show you is where we're multiplying by this least common denominator. So your first step that you want to do is you want to go through, and if there's any factoring in your denominator, you want to do that first. That way it can help you figure out what would be that common denominator, at least common multiple. So the first one here, nothing factors. We have x's, 4, and an x in our denominator. So our least common denominator would be a 4x. That way we have the x goes into the 4x, the 4, and then the x. So what I'm going to do is I am going to multiply each fraction by that 4x. And you want to make sure you do it to both sides of the equal sign. That way it keeps the equation balanced. So you're just doing it to the numerator. The reason we can do it just to the numerator, we don't have to do it on top and bottom, is that we're doing it on both sides of the equal sign. So then what you're going to do is we're going to go through and look at each individual fraction, and some part of that denominator should cancel with some part of this least common multiple that we used. If your denominator does not cancel, it means you are not multiplying by the right value. So what this will look like, we have the x is going to cancel with the x. Here, the 4 cancels with the 4, and then the last one, the x, cancels with the x. Then you're just going to write what's left. So I have, on top, I have a 5 getting multiplied by the 4 that's left, plus 7 that's getting multiplied by the x that's left. I guess I didn't need parentheses there, but I already wrote them, so it's fine. And then we have a negative 9 that's getting multiplied by the 4. This gives us our equation that we're then just going to use to solve for x. So this gives me 20 plus 7x equals negative 36. Subtract the 20 over, gives me 7x equals negative 56, and then I'm going to divide both sides by 7 to get x by itself. Negative 56 divided by 7, that gives us a negative 8. Okay. All right. So that's going to be the general process for all of these. They're just obviously going to look a little bit different depending on just what the initial problem is, but that's that same basic process. All right. So looking at our next one, there's no factoring we can do here. Anytime you have a whole number, basically you just don't have to worry about its denominator for that because it's essentially over 1, which is technically part of the least common multiple anyway because it's a 1 and 1 goes into everything. So anytime there's just a whole number term, just basically ignore that when you're creating that least common denominator. So we have an x minus 5 in the denominator. And then we also have just a single x. So that least common multiple, least common denominator is going to be an x and an x minus 5. So you do want to make sure that you're multiplying that by that 1 that we have in front there, even though it doesn't have a denominator. All that means is there's just no part of that that can cancel then, since there's nothing on the bottom to cancel with it. So then I'm going to go through, cancel what we can. So again, the 1, nothing to cancel. Here the x minus 5s can cancel. This one, the x's can cancel. So then I'm left with 1x times x minus 5, or just x times x minus 5, minus 8 times the x equals 3 times the x minus 5. Okay? So again, we just put what the original numerator was multiplied by what portion is left of that least common multiple. So then I'm going to go ahead and distribute. This gives me x squared minus 5x minus 8x equals 3x minus 15. You'll notice I made sure I distributed everything as needed. Scooch this up a little bit. So with this one, we ended up with a quadratic equation. We have the x squared in there. So anytime you have a quadratic equation that you end up with, I'm going to make a little note here. you want to set it equal to 0, and then we'll use that equation to solve for x. So this is quadratic. So set equal to 0, then solve. All right. So I'm going to go ahead and just bring everything over to the left since there's more terms over there already. We have a positive 3x, so I'm going to subtract 3x from both sides. We have a negative 15, so I'm going to add 15 to both sides to cancel that out. That gives me x squared, and I'm going to combine my x's, make sure you get all the x's in there. So negative 5x minus 18, or minus 8x is negative 13x. Negative 13x minus 3x would be a negative 16x, and then we have the plus 15 equals 0. And then it's up to you how you want to solve your quadratic equation here. This one is factorable, so I'll just go ahead and solve by factoring. So x times x is x squared. We're multiplying and getting a positive, so that tells me same signs. We're adding up to a negative, so it has to be negative and negative. So we're saying what multiplies to 15 adds up to 16, it'd be 15 and 1. And remember your solutions after you solve by factoring are what makes each factor equal to 0. So we have x minus 15, so that would be x equals positive 15. X minus 1 would be x equals positive 1. So we have two different solutions that would work on that one. X can be 15 or x can be 1. And again, obviously you can check your answers, just plug it back into the original equation. Make sure you get the same thing on either side of the equal sign. Right. So these word problems, we decided we're not going to worry about testing over these, so we are just going to skip. This is more of the same, so we're going to skip. All right. So this says here, when solving rational equation, you may obtain solutions that are extraneous. So if you guys remember, extraneous means that you solved it correctly, but it doesn't actually work if you put it back into the equation. So to check it, you just want to make sure that, make a little note here, be sure to check for extraneous solutions by checking your solutions in the original equation. So basically what that means is the extraneous solutions are going to come from the fact that you might end up with a solution that's actually one of your restrictions based on what would make the denominator equal to 0. Remember, we don't ever want a 0 in our denominator. It's breaking math rules, can't divide by 0. So if one of your solutions makes it so you have a 0 in your denominator, that solution does not work. That means it's extraneous. So you solved it correctly, but it doesn't actually work. So you always want to plug your answers back in. Make sure you're not getting any zeros in the denominators. Okay. So first step though, again, you won't know going into it that it's going to have extraneous. That's just one of those things you want to be aware of. So you're checking for that. So first thing I'm going to do, I'm just going to rewrite this and also factor my denominators as I go. So the x minus 5 and the x minus 3, those don't factor any further. We have the 2. And then this would factor to an x minus 5, x minus 3. The nice thing with these is there's a good chance that when something factors, it'll match some of the ones that are already there. So if you get stuck, you can always say, well, I have this x minus 5 and x minus 3. Maybe that'll appear somewhere in here. Okay, so then our least common multiple, we need to have an x minus 5 and an x minus 3. So I'm going to multiply every single one by this. And a common mistake that I have seen people make on these problems is not wanting to actually rewrite this, the least common multiple, like where I'm writing it for each fraction, and try to just keep in their head like, okay, well, what part of it's going to be left? Yes, that works if you're careful. However, our brains are bad sometimes. It's hard to keep all the numbers in there and keep things straight. So I always recommend just taking the time to actually write this and cross out the ones that you cancel out and things like that. It'll just help you from making little mistakes or just messing something up if you're trying to just kind of keep it all in your head. All right. So I multiplied each fraction by the least common multiple. I'm going to cancel the portions of the denominators that cancel. So the x minus 5's cancel, x minus 3's cancel, x minus 5's cancel, x minus 3's cancel. So then I'm left with, I have a 1 times the x minus 3 plus an x times an x minus 5 equals 2 times nothing extra left there. Scooch that up a little bit. So I'm going to go ahead and distribute. That gives me x minus 3 plus x squared minus 5x equals 2. So again, I ended up with a quadratic equation, so we need to get it equal to 0 to solve. Since there's just the 2 on the one side, I'm going to go ahead and bring that over. And then just make sure you're not missing any of the terms. These are all in like random orders. They're not listed in standard form, so just make sure you're careful and you're not like combining things together. All right, so we have the x squared and then we have x minus 5x would be a minus 4x, and then minus 3 minus 2 would be minus 5. Okay. And then again, we can factor to solve. This becomes x minus 5, x plus 1, which means my solutions are x equals 5 and x equals negative 1. If we look, though, based on our original denominators, but x cannot equal 5 or 3. Those are my two restrictions. So 5 doesn't work. That's one of our restrictions. So this is going to be my extraneous solution. Yep. So that means we solved it correctly, but it doesn't actually work if you plug it back in. And then negative 1 is not a restriction, so that one is fine. Right. So again, we've seen the general process. I'm just going to keep going through and just doing additional examples just so you can see just more examples are just helpful. All right, so I'm going to rewrite this just so I don't have to try to smush my least common multiple in there. This time the denominator is already factored for us. Awesome, saves us a step. All right, so our least common denominator for this, we need an x plus 2, an x minus 2, and then the last one just has both of them already. So again, I'm going to multiply it by each fraction. I know it's mildly tedious doing this step. Please actually do it because it will help you from making mistakes. All right, so if we look, I have an x plus 2 cancels the x plus 2, x minus 2 cancels the x minus 2. This one, the x plus 2 and x minus 2's all cancel. So I am left with, I have 1 times the x minus 2 plus 1 times the x plus 2 equals 4. Multiplying by 1 doesn't really do anything. You don't really need to write that part. I'm just showing what was there times what was left. So I'm just showing it. Again, you can go straight into just writing x minus 2x plus 2. It's fine. Let me just rewrite that really quick. So we get x and x is 2x. Negative 2 plus 2 cancels out. And then we have equals 4. I'm going to divide both sides by 2. That gives me x equals 2. Our restrictions, we have but x cannot equal negative 2 or positive 2 based on those original denominators. That means positive 2 does not work. This is extraneous. So we did not have a second answer, a second solution for this. So if your only solution ends up being extraneous, or even if you have two solutions but they both are extraneous, what that means is no solution. So it is possible to have a no solution on this if your answers end up being extraneous and there isn't a non-extraneous answer. Alrighty, so here's another one to look at. Again, you wouldn't necessarily need to do this. I just like to have room to write all my stuff out. So I'm just going to rewrite it so I have a little bit more space because I like to write bigger. So my common denominators here, I have an x minus 2. Technically the 7's over 1, another x minus 2. So my common denominator is just going to be the x minus 2's. So again, we do every single thing by it. Make sure you don't forget your whole number. Here the x minus 2's cancel, nothing to cancel there, x minus 2's cancel. That leaves me with a 5x times nothing left equals 7 times an x minus 2 plus 10 times nothing left, so just the 10. Gives me 5x equals 7x minus 14 plus 10. So on this one, I do not have a quadratic equation. There's no x squared, so we just do normal solve for x, get your x's by themselves. So since I already have some x's on the left, I'm going to bring my other x's over. So I'm going to subtract the 7x over. That gave me minus 2x equals, and then negative 14 plus 10 would be negative 4. I'm going to divide both sides by negative 2. It gives me x equals negative 4 divided by negative 2 becomes 2. However, our restrictions, we have x minus 2 in the denominator, so x cannot equal 2. So that means that one doesn't work. This is another example of no solution. Here's another one. Looks kind of similar to start. Actually, this one's kind of spaced enough. I'm going to go ahead and just multiply each thing. So in the denominators, we have an x minus 3, an x minus 3, and a 4. So that means our common denominator needs a 4 and the x minus 3. So I'm going to do 4 times the x minus 3, 4 times the x minus 3, 4 times the x minus 3. So for the first one, the x minus 3's cancel, x minus 3's cancel, that one the 4's cancel. So that leaves me with a 3 times the 4 equals x times the 4 minus x times the x minus 3. We'll go ahead and multiply. It gives me 12 equals 4x minus x squared plus 3x. Careful with your signs there. So then again, we want to go ahead and get this equal to 0. Even though there's less terms on the left side, I am going to go ahead and bring everything over to the left. I like to just keep my x squareds positive. Just makes it easier to factor. So I'm going to subtract the 4x over to cancel that. I'm going to add the x squared, cancel that, and then I'm going to subtract the 3x, cancel that. So that gave me x squared minus 7x plus 12 equals 0. And then we can factor to solve. That would be an x minus 4, x minus 3. So our answers, we'd have x equals positive 4, x equals 3. Let's look to see what our restrictions are though. But x cannot equal, we have an x minus 3, so x can't be 3. And then just the 4 does not make a restriction since there's no x with it. There's nothing that just makes 4 equal to 0. So x can't be 3, so that's my extraneous solution. So then my only answer is going to be x equals 4. Right. And then just a couple more of these, again, just so you can see it, extra examples. So this one, we have in the denominators x minus 3's and nothing, so we're going to multiply everything by an x minus 3. First one, there's nothing to cancel. Second one, x minus 3's cancel. Third one, x minus 3's cancel. That leaves me with x times x minus 3 plus 6 times nothing equals 2x times nothing. Go ahead and distribute. It gives me x squared minus 3x plus 6 equals 2x. I have a quadratic. Get it equal to 0. I'm going to subtract the 2x over. It gave me x squared minus 5x plus 6 equals 0. And then I'm going to factor to solve. That'll be an x minus 3, x minus 2 equals 0. So then our solutions, what makes each of the factors equal to 0? So x equals 3, x equals 2. Double check for extraneous, but x cannot equal. We have an x minus 3 in the denominator, so x can't be 3. That's my extraneous then. The 2 is fine. So that would be our solution on that one then. Right. And then our last one. This one's just a little bit different looking. We have the x plus 5's in both denominators. So technically we could cross multiply on this since it's just single fraction equals single fraction. But I'm just going to do it the way we've been practicing so you can see that that always works. So this method that we learned today, it always works. Cross multiply only works for something like this where you have single fraction equals a single fraction. So if we use the least common denominator method here, we'd multiply both sides by the x plus 5's. The x plus 5's end up canceling for each, so then we're just left with an x squared equals 25. So this is a quadratic. You could subtract the 25 over and then factor to solve. It would be a difference of squares. Easier though, since it's just x squared equals a number, we can just square root both sides to cancel out the squared. So that'll give me x equals, anytime we square root, plus or minus, and then square root of 25 is 5. Still check for restrictions though, but x cannot equal negative 5 since we have the x plus 5 in the denominator. So the negative is my extraneous. There we go. So our answer is just x equals the 5 then. And then these, more word problems. Skip it, and we're done. And that is it for chapter 4. Get out of here.